Today we're going to learn how to write something in polar coordinates. You're used to finding a point P, in what's called rectangular coordinates, where we start at the origin, we move over X amount, up Y amount, and the rectangular coordinates are the point X, Y. Today we're going to learn how to get to that exact same point using rectangular coordinates.
Please meet with Coach Truesdale now. All girls next year. Basketball players.
So you can see here, polar coordinates mean from this x-axis, how many degrees or radians do I move up, what is the angle, and then what is the radius, how far does it take to go from the origin or the pole out to that point. So you'll notice I'm at the exact same point P, but now it's called R theta. What's the radius that you moved out and the angle that you moved up? These are called polar coordinates for that same ordered pair. Okay, so if I ask you to plot the point A, that's 470 degrees, I want you to take a minute and go do that. At least think mentally where 70 degrees is and how you would use a radius of 4 on it. Hopefully you were able to visualize something that's very similar to this. You're going to go up 70 degrees, and whatever unit you decide to mark off, 1, 2, 3, 4, that's where point A would be. Okay, now mentally try to locate the point. 200 degrees, 3. So think what quadrant you're in for 200 degrees. So hopefully you said you're in quadrant 3, and then you're going to go out 3 units. Again, could be the same basic units, or you can make them smaller or larger as long as you mark them off. You should be able to see that you're going to go around 200 degrees and then go out 3, and there would be point B right there. Okay, so that's how we work with finding polar coordinates on a grid. Now I'm going to talk to you about the fact that in polar coordinates you can also have a negative radius. A negative radius simply means instead of going in the positive direction, which is the ray in which this angle ends or terminates, you're going to go in the opposite direction. So if we were going to go 50 degrees, the ray would terminate at that 50-degree angle, but instead of going into quadrant 1, we're going to shoot back negative 3 units into quadrant 3. So it would look like this. Instead of going up 50 and out 3, we're going to go up 50 degrees, and this would be the terminating ray. Instead of going in the positive direction on the terminating ray, we would go in the negative direction. So point 3 would end up being in quadrant 3. So I would like you to mentally think, where do you think, or what quadrant do you think the point D, which is -5 and 120 degrees, would land? Well, since 120 degrees is in quadrant 2, that would be where the positive radius is, but we want the negative radius. So we're going to shoot back, and it should put you in quadrant 4. So you can see here that D would go around 120 degrees. Instead of going out positive on that terminating ray, we would move a -5, and point D would be down here in quadrant 4. All right, so let's look at some different ways that you can label the same point. If I wanted to rename point C in 2 other ways, stop and think. Here's point C. What is another way that I can get to this exact same point? One way is to be able to go around the circle, positive, and then out positive. So let's see, that would be, since we are 50 degrees away from the x-axis, if we took 180 and added 50, we would be going 230 degrees and out a +3. Since 230 degrees, this is the terminating ray, positive would be coming out in this direction. It may seem negative, but this is a positive angle or positive units for a 230 degree angle. Another way would be to go negative. Well, since this is a -180, back one, that'd be -130 degrees, out a +3 as well. A fourth way might be to go all the way -310 degrees. So start here and go all the way around a -310 degrees and then instead of going out positive, go back a -3. All of those get you to the same point. If you wanted to do the same similar type of thing for -5, 120 degrees, you could go all the way around. Since I'm 60 degrees away from this, that means I would be all the way around 300 degrees, out a +5, which is the third one down here. Or I could go simply a -60 degrees, out a +5, or maybe I would want to go a -100, what would that be, -240 degrees, and then out a -5. All of those are going to get you to point D right here. All different ways to write the same point. Okay, now we want to talk about changing polar to rectangular and rectangular to polar. To change polar to rectangular, I want you to remember that the cosine of theta is the same ratio as the x values to the radius of the circle. The sine of theta is the ratio of the y values to the radius of the circle. Therefore, if you multiplied both sides by r, you could come up with x equals r cosine theta, and multiply both sides by r, and you could get y equals r sine theta. We're going to use this. This is critical. So I've started. This is how you're going to change things from polar to rectangular. So you'll notice here, we're going to ask you to change 6 -pi/6 into exact rectangular, or rectangular form with exact values. So you'll notice that when you take and do x equals the r value, which is 6, cosine of -pi/6, remembering that -pi/6 is in quadrant 4, so you have positive radical 3/2, -1/2 for the coordinates. You're going to get 6 times, the cosine there will be positive radical 3/2. You're going to get 3 square root 3. The y value is going to be the radius, which is 6, times the sine of the angle, -pi/6, which is the sine value there, -1/2. So 6 times -1/2 is -3. So the x coordinate will be, for the rectangular, positive 3 square root 3, and the y value will be -3. This will be the rectangular coordinates for this polar coordinate. All right, so let's try one more. Now let's try to give me 3 110 degrees to the nearest tenth of a unit. This is where you would just use your calculator and plug it in. So let's try that. If we punch it into our calculators, you're going to get x equals -3, because that is our radius, times a cosine at 110. So that'll be a negative value, so a negative times a negative, you'll notice when you punch in your calculator, is going to be 1.026. But 110, the sine, will be a positive value, so when you multiply it by a -3, you're going to get a negative. So 1.0 and -2.8 are the rectangular coordinates for this polar coordinate. Notice this is, if you go 110 degrees and back in to quadrant 4, this is also a quadrant 4 angle, or point. Okay, now let's see what we would do to change it the other way around. If we wanted to change from rectangular to polar, we would need to remember a couple of other things. This time, we need to remember that x squared plus y squared is r squared when we're on a circle. And the tangent of theta is y, the ratio of y to x. So if they ask us to give the exact coordinate in degrees for the point -4, -4, first of all, you need to use your x squared plus y squared is r squared. And the fact that the tangent of theta equals -4 over -4, or y over x. We're going to start off and do -4 squared plus -4 squared is r squared. Get 32 equals r squared. Take the square root, and r now can be plus or minus, because this time, remember, in polar you can have a negative radius. 4 square root 2 when you reduce the square root of 32. The tangent equals 1. You can punch that in your calculator since we're asking for it in degrees, and it's going to give you 45 degrees. Now you have to think. You know that it can also give you 225 degrees. So in degrees, you have to look and see that the point -4 is a quadrant 3 angle. So you have to make sure when you give your polar coordinates that you are in quadrant 3. If you want to use a negative radius, you need to use a quadrant 3 angle. So 225 degrees and then a positive 4 square root 2. If you wanted to use the 45 degrees, you would then need to use the negative radius to back it into quadrant 3. Or you could actually go all the way around and do negative 135 degrees coming down this way and out a positive 4 radical 2. There are multiple ways to write the point -4 into polar form, and all 3 of these would be correct. The last one I would like to do is for you to give the exact value of the point -3 square root 3 in radians. So give those coordinates in radians. So we're going to do the same thing we just did, which is x squared plus y squared is r squared. And nicely enough this time, r comes out to be a nice even 6. So you get r can be plus or minus 6, and then you're going to find the tangent of theta can be -3 radical 3 over 3, the y over the x, which reduces to negative radical 3. Therefore, theta can be 2 pi over 3 or 5 pi over 3. So when you go to quadrant 4, because you'll notice up here that -3 radical 3 is in quadrant 4, you can do -6, 2 pi over 3, because this is a second quadrant angle and the -6 will back you down into the fourth quadrant. You can do 5 pi over 3 positive 6, because 5 pi over 3 already is in the fourth quadrant. Or you can simply do negative pi over 3 positive 6, and also be in the fourth quadrant. So any of those answers would be considered correct.